All right, ladies and gentlemen. So, last section of the year, logarithms, okay? So check it out. 2 to the first power, that's a power. Okay, this is the exponent here. 2 to the first power is 2, right? And then we have 2 to the second power is 4, 2 to the third is 8, 2 to the fourth is 16. But what about 2 to what power is 9? You see? So here we don't know what the exponent is. So we're going to use logarithms to help us figure out what power I can raise 2 to get 9. Okay, so notice if I use a calculator, 2 to the third power is 8, 2 to the fourth power is 16. So 2 to the fourth power is too big, right, to give me 9. I need to get less than 16. I need to get 9. And I need to get more than 8. So it's going to be between 3 and 4. It's going to be like 3 point something, right? So let's say I try 2 to the 3.1. 2 to the 3.1. That's not, it's closer than 8 is, but it's not exactly 9 yet. So let's try 2 to the 3.3. And that's a little bit over, right? So let's try 2 to the 3.2. And that's more than 9 again. So it's going to be 2 to the 3.11. Let's try that. And you see, so logarithms will help us get the exact answer, okay, without having to guess and check like I was just doing right now on the calculator. So notice here, logarithms help us solve for the exponent. So for example, this here, 2 to what power is 9, can be written as a log. And this is how you write it. Notice here, the base here of the log is 2. Okay, because we're trying to find out 2 to what power is 9. So log base 2 of 9 is going to give us the answer. Now we know it's going to be 3 point something. Okay, because that's what I was doing right now on the calculator. It's going to be 3 point something. We just have to figure out exactly 3 point how much. So for that we have the change of base formula, okay? So basically what we do here is, notice on the calculator I have a log key. Okay, L-O-G. Now, this log key, if I want to know, for example, log of 5, I would just type log of 5 and it'll give me the answer, right? Now, notice here, there is no base here on the log, okay? Right here, I have a base of 2. Right here, there is no base when I type in log of 5 or log of 7 or log of whatever number. Notice there's no base there. Well, actually there is a base. It's base 10. So if you don't see a base written there, then that means it's base 10, okay? So if there's no base indicated, then it means base 10. But in this case, the base is indicated. That means it's 2. Why? Because it means 2 to some power is 9. So this is what that means. 2 to what power is 9? Okay? And so we use a change of base formula. Notice here, we have log base A of B is equal to log of B divided by log of A. So using this format here, I can rewrite this as log of 9 divided by log of 2. And it'll give us the exact answer. So check this out. I'm going to do log of 9. Oops, let me clear this. Log of 9 divided by log of 2. And I get 3.169925 and the rest of it, right? So it'll be 3.1699. Let's just go out 4 digits after the decimal place. And if this were to be a 5 or bigger, then I would have to round this up to 3.17, okay? And so this is it. Check it out. So this is saying that 2 to the 3.1699 is approximately 9. Now, I'm saying approximately now because I left off these digits right here, right? So check this out. 2 to the 3.1699 is 8.9998, which is basically 9, right? But I left out those digits. Let's see if I would have just rounded up to 3.17. Let's try that. 2 to the 3.17. And notice that gives me the exact one, 9.000. So let's just go ahead and round this up to the 2 digits after the decimal. Okay, so this will be 3.17. It'll give us a more accurate answer. Okay, So that's what we're going to do now. We're going to go ahead and do a bunch of examples here using the change of base formula. So again, let's look at this. If there's no base indicated here, then we know the base is 10. And then if there's a base of 10, then we just have to use the log key. We don't have to use the change of base formula, okay? So let's go ahead and practice here. Notice here. This is saying 7 to what power is 49? Okay, so let's do this off to the side. 7 to what power is 49? Now you know that already. 7 to the second power is 49. So the answer would be 2 right here. See that? But let's go ahead and do the math anyway. Let's do log of 49 divided by log of 7. Watch this. Log of 49 divided by log of 7. And I get 2. You see? So the answer is 2 right here. Okay? What about this? This means 8 to what power? 8 to what power is 512? Okay? Now I can do this a different way here. I can just keep guessing 8 times 8. Oops. 8 times 8 is 64 times 8 is 512. So how many 8s did I multiply there? I multiplied 3. Right? So this would be equal to 3. But let's use the change of base formula. So this would be log of 512 divided by log of 8. Do that on the calculator. Log of 512 divided by log of 8. And I get 3. Again, what are we solving for? The exponent. We're solving for the exponent here, okay? What about this one here? Log base 3 of 81. That really means 3 to what power is 81? Remember, we're always solving for the exponent. That's what logarithms help us solve for. Okay? So I could just do this. 3 times 3, not enough, times 3, not enough, times 3. That's 81. Okay? So how many 3's did I multiply? I multiplied 4 of them. Okay? And so my answer is 4 right here. But again, using the change of base formula, that would be log of 81 divided by log of 3. Log of 81 divided by log of 3. And I get 4. Okay? Let's do this one using the change of base formula right away. So log of 64 divided by log of 2. Remember, we're not taking 64 and dividing it by 2. 64 divided by 2 is 32, but that's not the answer. Notice we got to do log of 64 divided by log of 2. Notice the difference. We get 6. Okay? That means that 2 to the 6th power is equal to 64. Let's see if that's true. 2 times 2 times 2 times 2 times 2 times 2. That's 6 of them. 1, 2, 3, 4, 5, 6. Does that give me 64? Yes, it does. Okay? Now, what about this one here? Notice, 7 to what power is 32? 7 to what power is 32? Well, notice here, if I do 7 times 7, that's already 49. That's more than 32. So I know it's going to be less than 2, right? Because 7 to the second power is 49. So this is going to be a number less than 2, but it's got to be bigger than 1. So here's where the change of base formula comes in handy. So let's do log of 32 divided by log of 7. So let's do that. Log of 32 divided by log of 7. And I get 1.78. And we're just going to round up to the 2 digits. So it'll be 1.78. That means 7 to the 1.78 is approximately 32. Okay? Look at this next one. The base is not indicated there. Well, if there's no base indicated, that means the base is 10. Okay? If the base is 10, this is saying 10 to what power is 5? Now, wait a minute. 10 to the first power is 10. So this has to be less than 1, right? It's going to be a decimal number. It's going to be a number between 0 and 1. So let's do the change of base formula here. Let's do log of 5 divided by log of 10. Okay? So let's do that. Log of 5 divided by log of 10. I get 0.698. So if I were to round this up to the hundreds place, then it would be 0.70. So 0.70. So I would round this up to 0.70 there. So that means 10 to the 0.70 is 5. Let's try that. 10 to the 0.70 is approximately 5. Notice I get 5.01 here. But remember that I said if there's no base written here, there wasn't, then I could just go directly to the log key on the calculator. So I could just say log of 5, and I'll get the same answer, you see. So I don't have to do the change of base formula when the base is 10. If the base is 10, or if it's not indicated there, that means it's 10, then I could just go straight to the log key. Okay? Let's do some more of these. Let's go into negative logs, okay? So check this out. This is saying 1/2 to what power is 8? So 1/2 to some exponent is going to give us 8. Well, let's go ahead and do the change of base formula. So let's do log of 8 divided by log of 1/2. Okay? So let's do that. So log of 8 divided by log of, now I'm going to go ahead and make a fraction here. So I'm going to open parentheses. So I'm going to put 1 over 2 and close it. And I get -3. Okay? Let's see how that works. If this is a -3, 1/2 to the -3rd exponent, that's the same as saying, oh, the reciprocal of 1/2 is 2 to the 3rd power. Okay, so this negative takes the reciprocal of the base here. So in other words, 1 over 2 becomes 2 over 1, which is just 2. And then I get 2 to the 3rd power. Okay, so 2 to the 3rd power is 2 times 2 times 2. That's 8. Okay, so you see how this is going to be -3 right there. That's my answer. That's the exponent I need to raise 1/2 to get 8. Next one. Let's do the change of base formula. Log of 1 over 27 over log of 3. Okay, so let's do that. So log of, and I'm going to do parentheses here because I have a fraction here, 1 over 27, I'll close the parentheses, divided by log of 3, and I get -3 as well. Okay, so check this out. So this is basically saying 3 to what power is 1 over 27. So if they're saying it's -3, that means, okay, the negative exponent means I need to take the reciprocal of this, so that's going to be 1/3 to the 3rd power. And if you do 1/3 times 1/3 times 1/3, or you can do 1 to the 3rd power, that's 1, and 3 to the 3rd power, that's 3 times 3 times 3, that's 27. Okay, so you see it works. Okay. Next one here, we have log base 16 of 1/4. So let's do the change of base formula just like we did this one. So it's going to be log of 1/4 over log of 16. So that's going to be log of 1/4, I'll make a fraction there, divided by log of 16. And I get -0.5. Now let's write this as a fraction. So I'll just hit this button here and it changes it to a fraction form for me, -1/2. So this is going to be -1/2. And the last one here. So notice we have log base 9 of 1. Basically that's asking 9 to what power is 1? Well, let's do the change of base formula. Log of 1 divided by log of 9. Let's do this on the calculator. So log of 1 divided by log of 9. And I get 0. So basically this is saying 9 to the 0 power is 1. Okay, so you can see how we use the calculator to get all of our answers, and that's how you're going to do it as well. Okay, that's it.